Okay, I have started the recording. So welcome to today's session. So unlike last week, I'm going to start streaming on Mondays and Thursdays. And to give more context, we have been going through the tour of OCaml. So let me just quickly show you the previous recordings. So it's available in my channel, both the tour of OCaml part 1 and part 2. Both are around 30 minutes each. I'm trying to keep the sessions short so it's easy for people to read. So the first tour of OCaml sessions, I didn't include the chat because I wanted it to be more like a lecture session. But in today's session, I am going to enable the chat, so feel free to post your thoughts or questions in the chat. And we will go through the values and functions. So if we go to the ocaml.org site, right, and if I scroll down, we covered the tour of OCaml. So now I am going to go through the values and functions section. So we will be trying to go to the examples. Hi Sabine, welcome to the stream. Thanks for raiding me. And I have enabled the chat from today's session, so we'll see how that goes. All right, so let's get started. I know we have gone through the basic syntax and semantics. Now we'll do more deep dive session in the documentation available from ocaml.org. So let's get started. Again, I'm using the documentation on one window, and then we have the ocaml.org play on the other. So we can actually try out the examples here. And feel free to ask questions on the chat as well. So let's get started. So in OCaml, we know that everything is an expression, has a value to it. So we can actually try these. So we have seen the basic data types, integer, float, and string. So just as a revision, let's try this again here, which is a string. So I'm just going to clear the output here and run it. That looks good. And then we can have integers, and then we have a function here, int of float. Let's clear the output and run it again. So we have 2 into 21 is 42 is another integer. So we're doing the integer multiplication operation. Then we have functions, which is int of float, which takes a float and returns an int. So everything is a value in OCaml, and then we have a type for each of those values. So I can use this function, for example, 9. And since I am doing float operation, I have to use the star dot 2.0. And I'm just going to clear the output here and run it, and it returns me an integer value of 6, right? And then we can have functions. So here's a function that takes an argument and just multiplies it to itself. So into an int, we can do IO in OCaml. So just run, and it basically returns a unit value. So in this example of, let's say, a hello world, we take a string argument to print inline function, and we run it, and basically returns the string hello world here. Right? So basic data types and values. Let's continue. We can have global definitions. So let's say we have the let construct to define the answer as 2 into 3 into 7, which is again an integer multiplication here. Clear the output. So we expect this to return 42. But we can also have local definitions. So in our case here, D is 2 into 3 in D times 7, right? So what does this mean, right? We have 2 into 3, which is 6 in this expression. D is 6 in this expression. So 6 into 7, it should basically return the same answer, 42, right? But then out of this scope, if I try to find the value of D, it should return an error saying it's unbound value because the scope of D is within this expression there, right? A more chained example here, continuing on the same thought. Let's try this example that D is 2 into 3 in that E is D into 7 in. So D is 2 times 3, which is 6. In this expression, E is equal to 6 into 7, 42, right? So we get the result of 252, right? That's a computed value. But then outside of this, if we try to ask for the value of D or E, it should basically say it's an unbound value, right? So that the scoping is important. There's another way of nesting. It's given here. Let's try that as well. D is equal to in E is equal to 2 into 3. It's a different way of writing the expression. E is equal to 2 times 3 in the expression E into 5 in D into 7, right? So it's just the computation there, and it returns the value of 210 again. Out of scope, if you ask for the value of D and E, it should basically return an error saying it's unbound value. So it's sort of to explain you the concept of binding. Let's continue. We have seen pattern matching. We will go through a separate module on how to use the list functions. So this is an example of a list dot split. So in this example, we see the definition of the split function. So what it does is it takes a list which has A and B types, and then it's splits it up into A and B list. Okay, so here's an example. Let's try that. So we have x comma y. I'm taking the first elements A of type A into x and the second type elements into B. So here I'm going to call split, and 1 comma 2. Remember that the individual elements of the list are separated by a semicolon. So we have 3 comma 4, 5 comma 6. Let's just finish the last element, which is 7 comma 8, and I'm just going to close. Let's clear the output and we run it, and we are able to see the x and the y list individually. So pattern matching is great, very elegant syntax, easy to read. We have seen record examples in the tour of OCaml, so we can also do the pattern matching for the respective components in the record. So here we have a name record which has a first string and a last name, which is also a string. Let's make sure that definition is correct. That looks good. And then we can give an example for Robin Milner, who has the first name of Robin and last name of Milner. I'm again making sure. Okay, syntax looks good. And then for the Robin instance, I can extract the respective values using just pattern matching. And so the first will get the value of Robin and last will get the value of Milner as a string. Right? It's pretty straightforward there. Good. We can also pattern match on unit. So, for example, here print inline takes the string, returns a unit. So this unit that it returns matches with this unit here, right? So we can pattern match on the output as well here. Of course, pattern matching can also be used on user-defined tuples. Let's take the example here of live person. Which has an int and a name. Let's run this, looks fine. And then we take an age value for the live person using the years as an integer, right? So first thing is, like, don't get too frightened with the syntax. The way to understand it is to break it down, right? So let me finish this one. Let me make sure this is correct. Okay. So how do you understand a complex expression here, right? The first thing is to break it down. So what this says is age, right, is the years, and we pattern match to get the value of years for a live person in this tuple here, right? So you have years is integer, and then you have name here, right? So we just match for the years and return the years, and we assign it to the age. Okay. We can also discard values during pattern matching. So in the case of the list.split, let's say I want to discard the first elements in the list that I split. So here in this example, hi learner0418, thanks for joining in. We are just going through the values and functions documentation from the OCaml.org site. I will make the recording available on the YouTube site as well, so you can try with the same setup. Have a the documentation browser on one window, have the OCaml.org play on the other, and then you can also try it on your own. Right. Let's continue here. We're trying to do pattern matching, but we're trying to see if we can ignore values that we're not interested in. So let's say you're making a JSON query to a web interface. Later on, I want to spend more time on the Dreamweb framework and how you can write cool web applications or port an existing, say, Ruby on Rails or Django web application, right? How can we do that? So a similar context, if you have a JSON response and you only want to take specific fields, right? You want to ignore the rest. So how can we do that? So that's a context example here. We're taking a simple example here to better understand the usage. So in this example, we ignoring the first elements for each pair. So let me just use those for demonstration purpose, and of course we ignore the first, we get the second element, so we have 2, 4, 6, right? That's good. Continuing along, we have seen binding and scope. So of course here we are using the the playground environment where you can quickly try things out. Once you become comfortable with the syntax, the semantics, and the usage, I will later on tell you how to install an OCaml compiler or a switch locally on your system, how to use UTOP, and then we also look into editor integrations and use that as you proceed to build bigger applications. Right now the focus is only on the syntax and semantics, and hence I'm not putting you into installation and configuration and so on and so forth. Right, that's the idea behind it. The idea is to get you bootstrapped really fast. Once you start enjoying the OCaml syntax, I don't think you'll want to try anything else. All right, let's continue here. We have let 20 is 20, so that's an integer. Of course, run it, it returns int 20. And then we can say let 10 is equal to 10 in 2 into 10. Again, a similar example that we did with the D and E variables earlier, right? So here in this case, it will be 10 is equal to 10 in this expression. So the 10 variable here is the digit 10, so it's 2 into 10 returns 20. But here it is out of scope, right? So if I run this again, it will say 20 is the first value 20 is for this expression, and then we have for this we have int 20, and then this is the unbound value here. Very good. Let's continue there and look at a floating point example. So you can of course have like top level expressions that you want to evaluate in the playground, and because I'm doing a floating point operation, I have to use the dot. We've seen that earlier. Oops. Okay. Let me clear the output and let me run this again. It gives me float, which is good. And I can do the same thing here as well. I only want the result. I don't want to reuse the value again in say a later function. That's a syntax. It's going to be the same result. Next, we look at inner shadowing. So when you create a name, you define it and bind to it. It does not change. So here I is 21, and if I say I is 7 in I into 2, this is 7 in this expression here I into 2, right? So that's 7 into 2, 14, right? So this is the inner shadowing there, right? If I now ask for the value of I, it should return not this, but this is this value here, right? Which is 21, right? This is the inner scoping here. And you will see once you start reading a lot of OCaml code, you will be seeing a lot of these let-in statements. Another kind of shadowing example here at the same level. So here h is 2 into 3, which is of course 6. I can do let e is equal to h into 7. So h is 6, 6 into 7, that should return me 42 as expected. And now I am defining h is equal to 7, which is 7 now. Now if I ask for the value of e, it doesn't get decomputed, right? We have not changed it, so it will still be as 42. This is the same level of definitions. Functions are values. You can pass functions as arguments. So this is an example of a max function. So I'm having two arguments here. the maximum of either 21 into 2, which is 42, or to take the int of string of 713. Of course, 713 is the larger of the two values, and hence we expect it to return 713. Right? So you're basically applying arguments to functions. Another example of a string function here, string dot starts with prefix. So prefix state, you want to match for state in this word stateless, right? So it, of course it does match, and hence it should return true. But I can also do say, just to see the false case, I can do something like this, and it doesn't start with state, and hence the second starts with expression should return false. Okay, so you can play around these with these examples when you are actually reviewing this content. We can also use the application operator. So here example, square root of 9 is of course 3. The application operator applies an argument on the right to the function on the left. So you can also use it like this. It's kind of useful when you chain several function calls, right? The same result, but it's more pleasant to read. So this example here, so here again, don't be frightened when you see the expression. Let's break it down one step at a time. So using int of string of 81, which is 81, and you're converting that into a float here. So it's 81, take square root, which is 9, returns 9 here, right? So let's try that. Of course, you have a lot of parentheses, and sometimes you might miss the parentheses, but it should help you. Right? But you can also write it as int of float of int. So the evaluation is from the right to the left, right? So it should basically return the same result. But you can also use the pipe operator if you have written Erlang or Elixir. I think they'll have this nice syntax. So you can do int of string. Actually, let me try writing it like this. It's easy to read. But there is a slight difference from the previous application operator. If you see, in this example, again we are doing int of string first, then we are applying the result to float of int, and its result we are applying to square root. These two are similar, right? But here we are writing int of string first, right? Then we are passing the result to float of int, to square root, and finally to int of float. You should still get the same result, but it's kind of nice to read. This is nice to read. It's more like prose, poetry. It's very conversant. All right, let's continue here. I think I'll finish with anonymous functions, and then we can pause for the day. Now we've covered a lot of these examples earlier in the tour of OCaml, but it's just good revision, and we'll deep dive into all these modules later on. So you can have an anonymous function here, a function x that just returns itself, or you can have a function that takes the argument and doubles it, or it concatenates two strings together. Let me check that I've not made any mistakes here. Okay, all looks good. I can also have a function that takes the list and returns none, or it constructs a new list. Split the list into head and tail. I don't care about the tail, I just return the head of the list. Right? Definitions look fine. So functions need not necessarily have to have a name. You know, anonymous functions. This is a good example here where we have a list dot map. It requires a function, and you apply the function to every element of the list. Right? What should the function do? So I'm not going to reuse the function anywhere else. I'm just going to call this anonymous function, which say list multiplies each element to itself. And I run this, and I of course get the result of an integer list of 1, 4, 9, and 16. Let's stop here for the day. We will resume with global functions and local functions from next Thursday, from this coming Thursday. So what I would like you to do is have a similar setup. Go through the values and functions document, try out each of these examples on the OCaml.org play. I will make the video available on my channel. So I uploaded the previous two recordings here, and I'll upload today's session as well. And if you go to my GitHub account and open the Twitch repository, I have the notes for all the functions that I have tried out here. Okay, so spend some time. I'm intentionally keeping it short so that whenever you're taking a lunch break or a break from work, you can try these small examples to get started in using OCaml. With that, let's see if we can rate somebody else who is streaming right now. I'm going to stop the recording.